Hello. This is the start of the Environmental Matters webinar series being put on by the City of Superior Environmental Services Division. And this is again part of a series, brand new. The next slide I'll show you what else is coming up so you know ahead of time. That these are being planned for twice a month. And you can see that at first we are changing the times around a little bit, times and days, that they're Tuesdays or Thursdays, and then it'll be that way through March, the middle of March through March 12th, and then we're going to Tuesdays only at noon. So beginning March 26th, they will all be held on Tuesdays. So join in. This is a list of some of them, and they will continue throughout the rest of the year, each lasting about 25 minutes or so. And then if you see on the bottom here that you can win a free rain barrel, and we will pick from Superior residents listening, and every time you attend a live webinar you'll be entered into the drawing, and we'll announce the winner in June. So thank you for listening, and we'll begin this first presentation, which is on smart salting for homeowners. I'm Wendy Grethen, and again part of Environmental Services Division. Jillian Edwards also has helped with putting this together. We did a version of this program back in December at the Superior Public Library. So the goal of the next 20 or so minutes is to learn more about road salt use, learn about its potential effects and how to use it effectively while protecting water quality. A little trivia about salt. The roots of the words soldier and salary can be traced to a Latin word relating to giving or receiving salt. It's definitely part of our history of trading salt, exchanging salt. It's an important commodity. An alchemist called it the fifth element, and there are over 10,000 uses of salt today. Where does salt come from? It can either be harvested from deep shafts, mining from deep shafts, and that is the source for Superior, Wisconsin here, that we get it shipped over and brought on the Hallett dock. We get it from Ontario. Another way salt is brought up is through solution mining, where wells are erected over where the salt beds are and water is ejected down to dissolve the salt, and then also evaporation from our oceans. Here's just a sampling of assorted products. You can buy salt in buckets and bags and containers ready for homeowners to use on your sidewalks and driveways and steps. Salt, again, is for melting snow, snow or ice. They are de-icers. They must be in solution to work first, and it'll be part of the process, and I'll explain a little bit about more of that later. And they're serving to lower the freezing point of water below 32 to a colder temperature. So again, salt as a de-icer is lowering the freezing point depression, it's called. The freezing point of water becomes lower as more particles are added, and this works up into the point where the salt stops dissolving. So by having more particles present, it reduces the amount of ice that forms. And this depends on the number of particles in a substance. Here's sodium chloride, which is cheaper than other types of salts that are used, such as calcium chloride. Sodium chloride has 2 ions, but calcium chloride dissolves into 3 ions. So it actually has more particles and thereby lowers the freezing point of water more than just sodium chloride with only 2. And I'll mention some more about calcium chloride as an alternate salt available. Here's a little bit more of how salt works. Water is always moving. Under cooler conditions, the molecules move more slowly. and more is captured by ice. So the water will become part of the ice and the surface of ice. When the temperature is raised, when it's heated, molecules move faster and melting is favored. So more goes into the liquid state. When you have salt present, it disrupts this equilibrium of going back and forth, and only the water freezes, not the salt material, so less water molecules are available as there are more salt or really just foreign material in the mix. And this works up to a point, and it can work with salt, it can work with alcohol, it could work with other materials that are used as a means of being a de-icer. So with the presence of salt, it's going more into the liquid form compared to going into ice. Looking at salt as far as use as on roads, it was first used in New Hampshire back in 1938. 5,000 tons were used throughout the nation in 1941-42, and today we're looking at 10 to 20 million tons. As far as winter, and this is information from the Wisconsin Department of Transportation, Wisconsin had an average of 37 winter storm events in the 2010-2011 season, about 100 inches of snow, and 573,000 tons of salt was used in the state, with a cost of about $2,696 per lane mile. The total winter costs were $91 million, which included both the cost of the salt and the equipment, plus the time involved, the labor. There definitely are benefits to using road salt. This graph is showing the reduction, the quite dramatic reduction of accidents after salt has been applied. And another feature about salt is when it's applied as a liquid, it can immediately begin to lower the melting point of water. As far as the city of Superior, we do have a snow removal ordinance in place. The residents must have all sidewalks, walkways, stairs, driveways, parking spaces, and similar areas kept free and clear of snow. And after a snow incident, all this clearing must be done within 48 hours. As the winter comes, and here we're in the middle of it, how much snow will come? We never really know, but we can be prepared and we can do certain activities after the snow. One thing we do know, eventually spring will come, and when spring does come, the spring runoff, and as well as if there'd be rain events, the storm water from rain will carry the water and the melting snow and all the dissolved salts with it and carry it to the nearest storm sewer, which in most cases in Superior, those storm sewers do go directly into our streams, rivers, and lakes. Just a comment about a question you may not have thought about before, but can water float on water? What happens when this salty water, the salt dissolved in the water and melting, what happens when that enters a stream or fresh water? The little diagram is showing you that basically the salt water, if it would enter, it would head right to the bottom. It's heavier and it's going to sit there and be its own layer. And this results in less mixing of a pond or a lake. It sits there on the bottom. This is a table showing you chloride levels. Here, sodium chloride or these other salts with chloride. Chloride is an important topic that we're going to talk about a little bit more later too. There's concerns of over chloride level in streams. But as far as salt storage areas, of course, those would have the highest quantity of chloride levels. But highway meltwater runoff also can have 5,000 to 20,000 parts per million. Snow piles in a parking lot where repeatedly snow is piled up and piled up those also can have 5,000 to 15,000 parts per million. And what we're trying to avoid is to have urban streams in the winter receive too much of this chloride level, but it has been shown, and I'll have some slides coming up of this chloride being found in urban streams. Normal freshwater does contain some chloride to it, and ocean water, where it's actually coming, some of the salts are coming from, it also has that. But we don't want, what we're trying to avoid is to have too much of the chloride enter our streams and lakes. Here's in the Madison area, over a 20-year span, over more than 20 years, what's been happening with the chloride levels found in their lakes, going up, up, up. As far as elevated chloride levels in streams, this USGS survey done back in 2009, sampling 100 streams in 19 states in northern Illinois, found that 40% of urban streams tested were found to have chloride levels above the recommended federal criteria set to protect aquatic life. And this increases in chloride levels in the streams during the last 2 decades are consistent with overall as we use more salt use. Just as a comment, other sources for chloride are the storage of salt, some septic systems, water softening, animal waste, fertilizers, landfills, and natural sources. The Minnesota Pollution Control Agency recommends chloride levels at less than 230 milligrams per liter, and that's about the equivalent of 1 teaspoon of salt per 5 gallons of water. Chloride, again, is something we don't want too much in streams, and once it's there, it's very difficult to remove from water. It's a costly process. So to look back at that amount of 1 teaspoon of salt per 5 gallons of water, if for every teaspoon less of salt you use, then you help to keep more water clean. This is some information on measuring what's present in water. There's something, the dissolved or soluble fraction of water's total solids load is the total dissolved solids, TDS. It's the weight of the material per unit volume, and this is expensive to dry out a sample and filter and come up with this. So another way to do it is through electrical conductivity, a quick, easy way to measure, and it provides a simple, inexpensive measure of the TDS. It's a measure of the water's ability to conduct an electric current. EC25, which is the common way it's done, means the data is standardized to 25 C temperature. And this, from the DuluthStreams.org website, has data on assorted streams. And this table, or this chart, is in red. The red line is showing the electrical conductivity going up following a storm, and you can see that big peak happening. I'll also play this short video. It's an animation of Tisher Creek, another Duluth stream, and the red is showing higher electrical conductivity in the stream. So following an incident, the electrical conductivity went up. Excuse me, I'm trying to remove it. There we go. So DuluthStreams.org has information on streams, and that electrical conductivity is a measurement of roughly getting into the salt presence in the stream, or you can see it go up after a storm. The effects of salt on roads and vehicles. Vehicles can corrode due to the salt. There can be damages to the concrete, to metal, and And then just in general, there's infrastructure costs. So as much as we can talk about using salt as a cost of the salt, and as far as application on the roads, it's the equipment and the labor. Well, it's also is a cost based on corrosion of the infrastructure. There can be effects on plants as well from the salt. This is just a list of assorted effects. Browning of the needles on the evergreen plants, where it looks basically as if it's burnt or scorched. There can be stunted growth, this witch's broom effect, where there's just little clusters of shortened growth, especially on the side facing the area that was salted. Delayed budding can inhibit seed germination. Elevated salt levels in soil can inhibit the ability of the vegetation to absorb both water and nutrients, which then slows plant growth. I did want to put in this website, which gives you information on how you can protect your landscape from road salt. StartRightStartHere.com had some information and tips on keeping your plants safer from the salt. As far as effects on animals, fish vary in their salt tolerance, and then some of the macroinvertebrates that the more tolerant species of fish feed on might exhibit lower tolerances to the salt. So some fish may be tolerant, but what they feed on may be more intolerant. Benthic diversity decreases as salinity increases, and dominance of salt-tolerant invertebrates is synchronous with the periods of road salt application. So the diversity of life goes down on these. Benthic is just at the bottom of streams and rivers. So from the study done in northern New York, they were finding this to be the case. And as far as our terrestrial organisms in the area, deer like salt and have been known to hang out closer to the road edge, which might increase incidences with deer and car. So it's winter time and you have snow to remove. What's the first thing you do? The number one best recommended thing to do is to use mechanical means to clear the snow and ice, and to do this as quickly as you can before compaction. And you in your own home, your own area, it's easier for you to do, hopefully, compared to people driving on it. If you can get to the snow first and use it. In the next slide, I just have an example of many tools that you can use. Recognize that there are a variety out there. For shovels, they come in different formats. The push shovel, a scoop shovel, there's fancy ergonomic handled shovels. So those are ways to get at the snow and the ice. There's even something called a push scoop, which that you don't ever have to lift the snow up and twist your back or anything. It's just pushing it along, kind of similar to mowing the lawn. The blower, snow blower machines, a simple broom can be effective with lighter amounts of snow. And then if ice has formed, there's ice scrapers or chisels that help to get down, get under there, break up the ice, make more surface area so more of it can be picked up and removed. And there's heavier duty materials, including a heat gun or torch, and then even a melting mat. A mat that's electric that automatically, with the temperature, will help keep you, keep an area snow-free and ice-free. As far as salt-type products, there are many available locally. This we stopped in at a few stores in town, and here's a variety of name brands out there. And then I've also included information on some of the temperatures that they're effective at. And you can see the range, that some stay only in the positive temperatures and some do go to lower temperatures. Some are a blend of materials. Some don't contain any of the chloride material, the glycols. So as far as what to apply, if you have done as much snow removal as you can, but you still want to apply some of the salt, be aware of the operating temperatures of whatever de-icer you're using, that it won't be functional, won't have any effect below the temperature that it says it can have effect down to. As far as how to apply the de-icer, that's another topic that we'll briefly talk about. Here's just looking at salt, the sodium chloride. There's two chart tables here. One is showing that here as the temperature goes down, salt has less ability to melt the salt at the lower temperature. So that's definitely a clear trend of it just doesn't work, and it's not going to work at these lower temperatures. It works best near freezing. This other one is comparing salt, which in this for this axis it's time, so salt will be melting some of the snow effectively there, but calcium chloride operating down to these lower temperatures can not only go to the lower temperatures, but it's doing it in a shorter amount of time than the salt. So that's just showing you a variation of two different salts, the sodium chloride versus the calcium chloride. And then a mix, some products come as mixes, and they then can cover going down to lower temperatures and being faster than the salt alone. This is a little table that I put together of some of the various products that are used and sold. Sodium chloride, which again is rock salt. It's the cheapest one and easy to find, and it works well at the temperatures when snow is falling, that it does not work well below 15 degrees. Magnesium chloride, also calcium chloride are available and assorted. Some are as liquid, some are as flakes or pellets, and they work down to the -10, which is much lower than the rock salt would. These actually give off heat as it melts, and it acts quickly. But they cost more, they still are corrosive, they still have the chloride present in them, and some can be slipperier at warmer temperatures, and they stain carpeting were some downsides of those non-sodium chloride one. Acetates are also used and available. There's calcium magnesium acetate, potassium acetate. These are non-chloride, which is good, and they have been used in more sensitive areas, but they also have a negative aspect that if they do enter a stream, that they can deplete the oxygen level in the stream or even in soil. They cost more, and they operate more at just those warmer, near freezing temperatures. And there's more variety of products available too, including plant-based additives, and some of these are just used with other ones, but they don't contain chloride, and they can help the other products stick in place, but they can contribute nutrients. But they are being made from beets, corn, and molasses. Often the combination works best, such as, again, having the sodium chloride with one of the other chlorides. As far as some tips on de-icing, there are some efforts to make liquid de-icers available and to do it before a snowstorm to prevent ice from forming. But otherwise, the number one recommendation is to try and remove snow manually, and before you need to apply any de-icer. Read the product instructions again, that again they just don't operate at certain lower temperatures. Some products have a little dye added to them, a coloring, so you can see a little bit better when you apply something that's whitish, clearish on whitish, clear snow. It's hard to see how far you, how much you've applied. So there's coloring to help you. You can also, this is on the how to disperse it, you can use a shaker and basically make your own from an old coffee container and punch holes in it, or use a spreader for a little bigger area like your whole driveway, and use that as a way to spread it more evenly. If you do spill, or if there's just more salt applied than needed, you can sweep it up and use it later. But overall, don't apply at the temperatures that it's not effective at, and don't apply during a storm. And then also, just another comment is, don't ever apply de-icers when there's 3 inches or more of snow present. This is a picture of a kernel of the crystalline salt added dry versus when it was pre-wetted, and you can see how much under the wet conditions it melts much faster. Here's a little bit more on the how to apply. I mentioned a shaker, which you can make your own. It lets you disperse it much more evenly compared to a cup or a scoop. If you just took an old cup or a scoop, sometimes that ends up having little piles in places which you don't need. A push spreader helps for the bigger areas, and they often do have a calibration tool to make sure that's being used and done properly. But overall, if you do feel like you need to put some salt down or de-icer down on your steps or your sidewalk, do so sparingly. And it's a little repetitive, but only under the correct temperatures that is recommended for the product. These are some photos of just some of the crystalline salt added in different scenarios, and to pick which one do you think has the most ideal distribution of the crystalline forms. The upper left is a bit piles, the other one is a bit too much, and then on the lower right that's might not be enough, and the one that has a better distribution is that. So you can kind of visually know that you're trying to spread it out. How much to apply? Fortin Consulting recommends a half cup for about 150 square foot area. More than that is not better. Applying more won't help. And applying too much not only adds cost, but it can more likely lead to some of these water quality effects in our area, negative effects. I mentioned there are other things besides the chlorides, and certain areas such as on bridges or at airports where they definitely don't want any corrosive action happening, they use acetate or urea, just some non-chloride products. Again, beets extracts have been used. In Polk County, Wisconsin, the county level is applying leftover cheese brine from a cheese processing place. You'll see calcium and magnesium chloride available, and then the glycol. In Grand Rapids, Minnesota airport, they don't use any salt at all. They do it all snow removal through a special sweeper. Sand can be used when the temperatures are lower than the other products would work at. It's great for traction, but it is not a melter of ice. It's only for supplying traction. And it needs to be on the surface. If it gets trampled down and below, then it's no longer effective. It's also still there after the snow melts, so it needs to be swept up and not down storm drains. Some effects from sand could be that it can cloud water or decrease stream quality if it makes it down the storm drains. And dust can form as cars ride over the sand, which can affect respiratory problems or people with asthma in some cases. And if you're concerned for safety for your kids and your pets, you can do your best to keep them away from the snow, areas of snow with salt present. You can choose to not use any of the salt and use sand or gravel. Some products are claiming to be safer for pets, such as a product called Safe Paw. And then for pets, there are booties you can get for trying to decrease the amount of salt that gets brought in or attached to your dog. And as we've moved along and looked at different things, I have a little quiz at the end here. What should you do first after a snow? And the answer would be you want to remove as much snow as possible. Shovel, whatever means, whatever tools you use. When should you not use sodium chloride products? Here it's cheap and readily available, but you do not want to use it if the temperature is below about 15 degrees. And then true or false, can salt be reused? And the answer is true, that if you have leftover, if you've applied too much for some reason, you can actually sweep it up and use it later. And then what I do on my property doesn't affect other areas. And it's false that what you do on your property does definitely affect other areas, especially as the seasons change or after rain moves it. Here's a few websites that you might want to take advantage of. We have linked to the City of Superior website this video by Fortin Consulting on improved winter maintenance, and it is for homeowners. It's about 15 minutes long. We've also been running that on community television in Superior too. The Department of Transportation website, both Wisconsin or Minnesota, has some tips on snow removal and information on storms and road conditions. LakeSuperiorStreams.org has some information on understanding the impacts of salt and has that data, like I was showing, a sampling of some of the salt or the electrical conductivity of streams, how that changes after a storm and the application of salt in the vicinity of the stream. So we will get winters up here in the Northland. Do your part to help keep your sidewalks clean. Safety is definitely important. We don't want people slipping. And then help your neighbors if you can. So thank you for helping keep our streams and lakes clean. And what you do does matter. And salt is definitely a topic of concern. And as a homeowner, a property owner, you do have choices to make and control of what you apply and how you treat your area. So hopefully this webinar has given you some tips of how to reduce the salt use or just use it sparingly and to know what products to choose. And so that would be concluding this webinar. And I do have a poll that I'd like you to take if you don't mind. This is just some information to learn more about so actually, let's see. I'm not seeing it. Let's see. And this is new. The polls have opened. So if you'd like to reply to this poll question, please. Are you concerned with salt and other de-icers ending up in local waterways, including Lake Superior? And then just Quickly, here's another one of have you ever experienced negative effects? And then we'll just try a few more here. Well, actually, maybe that'll conclude the poll. But really to just overall think of, have you had effects from salt, and are there things you can do to make a difference in the water quality in our area? Thanks very much for attending. And this will conclude this webinar. And again, please participate in upcoming webinars. Information is available at the city website, www.ci.superior.wi.us/webinar.